Hello, in this video I'm going to talk about a reaction map of carboxylic acids and carboxylic acid derivatives. And a reaction map, the reason I'm doing this video is to give you some insight into how I think about writing multi-step reaction or multi-step synthesis problems. And I'm also hoping that you can use it as a tool for studying for quizzes and exams in organic chemistry. So I'm going to kind of walk you through a reaction map and different types of problems that could be constructed from a reaction map. Okay, and we're going to focus. This could be used for different types of functional groups, but since we're in the section on carboxylic acids and carboxylic acid derivatives, I'm going to focus on that because it's most relevant to the next quiz I'm going to write. And so if we look at carboxylic acids here, we've seen three ways that they can be synthesized in chapter 21. So we can get them from primary alcohols. We can also get them from alkyl halides via two different routes. And both of these routes, you add a carbon to the alkyl halide to make the carboxylic acid. I'm not going to show all the conditions on this slide because that would have taken more time to build this. And two, I'm trying to show you the relationships. That's what I'm trying to kind of get you to see. I'll show some reagents for three of these reactions on another slide. Okay, so that's how we can get to carboxylic acids. We also know that we can take carboxylic acids and we can make a couple other different types of functional groups. So we can make acid chlorides, or we can make esters via the Fischer esterification. We can also do reductions of carboxylic acids to maybe make alcohols or aldehydes, but I completely forgot to put that on quiz 9. I think I might have forgotten to put those on quiz 8 too. So they'll probably end up on a future quiz or exam. So, all right. However, another thing we've learned recently is favorable interconversions of carboxylic acid derivatives. Okay, and so you can see I've got these different colors to kind of indicate different types of, or a different way of kind of organizing these reactions. Okay, and so you can see using these arrows we can get between different groups. Kind of like if I was flying from Grand Rapids to Seattle, maybe, I'm not even sure I could get there directly. Most likely I'd have to fly through Detroit or fly through Chicago or fly through Denver. And something similar happens with organic reactions. If I want to get to an acid chloride from a primary alcohol, well, maybe we could do it directly. But the way we know how to do it, based on the last couple chapters, is go through the carboxylic acid and then go to the acid chloride. Okay. And so we can use this map, okay, to think about different ways of kind of testing our knowledge of getting from one group to another. Okay, so let's say I wanted to write a question where I wanted to see if you were able to get from a primary alcohol to an amide. Well, I would kind of based on my reaction map, I could see that I've got this route here. That's a possibility. Okay, and so then I can start, filling in reagents possibly, or not filling in reagents, and I can write different questions. Okay, so let's take an actual example, kind of using this route. So now we're going to need to determine what our primary alcohol looks like. So I've chosen something fairly simple here, 1-propanol. Okay, to get to the carboxylic acid, we need to use a stronger oxidizing conditions such as potassium chromate and sulfuric acid. We also know that we can get from the carboxylic acid to the acid chloride using thionyl chloride. And then lastly, we can we can do a conversion of an acid chloride to an amide using ammonia. And we could either use sodium hydroxide or pyridine, or we could use a second equivalent of ammonia. So this is something we learned more recently. Okay, And so now, kind of looking at this entire sequence of three reactions, you can see we have basically 7 pieces of information here. We've got 4 structures, okay, and we've got 3 reagents. Now, another thing I want to note here, in this particular sequence, we're just changing the functional group. We're not changing the number of carbons. However, there are reactions that we've learned even recently that change the number of carbons, particularly the ones that go from an alkyl halide to a carboxylic acid. So we learned a sequence that was like magnesium followed by carbon dioxide followed by H3O+, and that carbon dioxide added a carbon to the chain. So it's also good to kind of be aware of what reactions are going to change your number of carbons or reduce your number of carbons. Okay, so what are some questions I could write based off of this sequence? So one is I could have something that's like predict the final product, and it would look something like this. So primary alcohol, and then these are the 3 reagents. So it could be written this way, and then you would have to predict the final product. To figure that out, you would have to know what each of these different conversions do. Another way we could write this is we could write them as a series, and 1, 2, 3, and this represents the same thing, that we've got an arrow for this step, and then we're going to have some product, and then we're going to have a second step that gets us to another product, and then a third step that gets us to another product. So it's the same, just a slightly different format for the same type of reaction. So I guess there's kind of 2 formats in here, format 1A and format 1B. Okay. A second way we could do this is we could say, okay, I'm going to give you a reactant and a product, and now I need you to tell me what reagents are going to get me from here to here. Okay. Or we could also write it like this, where you would write the reagents in here. So that's the second type of question I could write. Okay. And then thirdly, and this is maybe a little more closer to what actual organic chemists might do at a pharmaceutical company. Maybe they need to synthesize something. And here I'm giving you a little bit of information. I'm saying start with something that's got 3 carbons and that's an alkyl halide. Oh, that's a typo. I'm sorry, that should be 3 carbon and alcohol. We're starting from an alcohol. Okay, so that might be a hard synthesis. Okay. But sometimes in like the real world, it might be like, hey, we need a compound that's about this size and has an amide in there because that's going to shut down, I don't know, some enzyme, and that's going to cure the common cold or something like that. Okay, and then, you know, the organic chemist would have to say, okay, how am I going to make this, and what can I buy that I can use to build this? All right. And then lastly, and I think this is kind of most fun because it's most kind of like a puzzle, is where you might be given, you know, little bits of the information and you have to fill in the rest. Okay, so it's kind of like Sudoku or, you know, some kind of puzzle like that where you're given these letters or numbers and you have to figure out what the other ones are. And so in this question, you're given the starting reactant, the final product, you're given one of the intermediate products, and you need to give the product of this reaction and then these 2 reagents. So that's another way this can be written. So I hope this is helpful. I'm sorry if it's not, but that'll give you some ways to think about how, at least know how I might write these type of questions, and maybe it can help you think about how to study for these type of questions. All right, thanks for watching.